Alrighty. Well, let me pray for us, and then we'll do our best to finish up our discussion on nematodes and to try to get back on schedule. So let me pray. Father, thank you so much for how you bless us and guide us. I just pray that you would continue to do that, and as you do that, we would be mindful of where you're leading us and how we can best serve you. We ask this in the name of Jesus. Amen. All right, so Angiostrongylus cantonensis. So in addition to these bits of information, one of the things that I've decided to do is, as we need to go through these nematodes, is, you have access to these slides, which are a great summary of the text, and hopefully save you some time as you're going through and trying to get the information without having to dig really deep into the text. I've decided that as we go through here, rather than just going point by point, I'll give you kind of where the present research is going with regards to these species. So, Angiostrongylus cantonensis. This is a really intriguing parasite in a couple of, or maybe in three different ways. One is it's one of the most obvious zoonotic parasites, in that it's very clear that we can see the normal definitive host for this are rats, and because of our close association with rats, this is something that has bled over into humans. So it's one of the clearest examples of a zoonotic parasite. And so that's a big area of research on this parasite, is figuring out what practices help zoonoses happen most easily. What is it about the way we behave as humans that make it likely that we're going to pick up parasites from some of the animals that live in close association with humans? So that's a big area of research in this parasite. Another big area of research is into how parasites move through hosts when it's not their normal host. So this is another parasite that has an affinity for the central nervous system. And so a lot of the research done in here is how does the way this parasite behaves and moves through the host impact the pathology on a host that's not normal. And the third area is spread. So this parasite is spreading quickly. And so it used to be restricted to Southeast Asia and some Pacific islands. That's where you see Southeast Asia and Oceanica. But it has now been found in California, it's been found in Florida, and it's been found in Central America. It's basically spreading to a lot of tropical and subtropical areas. And so because of that, this parasite is of particular medical and economic importance. So here's an image. Here's the first intermediate host is a snail. And the way we tend to get it as humans, although sometimes we'll get it, from interacting close to rats and getting access to the eggs, is from the larvae that are inside of the slime trail on snails. So here's a snail chewing on some lettuce, leaving behind its wonderful gift of a slime trail. And inside of that are some larvae of this parasite. And so here's that illustration of the main way in which we contract this is by eating lettuce contaminated with the larvae. Now, it is also possible from eating secondary hosts of this parasite, what you would call paratenic hosts that help transmit the parasite from snails to rats, but aren't necessary for the development of the parasite. All right, so the next chapter of nematodes, we're talking about the human and intestinal roundworm and similar. These are some of the largest of all of our nematode parasites, and some of the nematode parasites that we've known about for the longest amount of time. All right, so the first group, Ascaris lumbricoides and Ascaris suum. Morphologically, these parasites, these two species are identical. But Ascaris lumbricoides is a human parasite. Ascaris suum is a pig parasite. So this may be zoonotic and came to us from pigs, or what I think is more likely is we actually gave it to pigs. And this was originally a human parasite. Yeah, so morphologically identical, we already talked about that. Known since antiquity. This is just a parasite we've known about for a really long time because these parasites are up to 45 centimeters in length. And so if you don't know what that is in inches, that's about 18 inches long. These are massive worms. And these are big enough that they can quite regularly block the intestines. They can get so dense in the intestinal tract that they can start to wander and move up your digestive tract and end up in your mouth. And so these are worms we've known about for a long time. Plus, basically, as long as people have been dying, there have been people studying their bodies to try to figure out various things. Maybe just to eat them, but oftentimes, to try to figure out more about the human body. And so this is a parasite we've known about for a really, really long time. And so one of the biggest areas of research with this parasite is in the area of autoimmune diseases and using material from this parasite or using the worms themselves to try to treat autoimmune diseases. Because this worm does a really good job at regulating the immune system. And so this worm does a really good job of escaping detection by the immune system by downregulating some portions of it. And it basically makes the immune system behave properly while at the same time avoiding detection. And so there are a lot of different groups doing research on can we use this to effectively treat Crohn's disease or to even treat asthma or MS, some other diseases where your immune system is attacking your own cells. Because this parasite does do a really good job of downregulating the portion of the immune system that tends to get carried away. So here's relative size of these. There's a whole bowl full of them, as if things weren't creepy enough. There's a whole bowl. There's relative size next to a penny. And so I know I talked about this several weeks ago, but it's been a while. So we have to meet during our scheduled final time. But our final is going to be on campus. But we are required to actually meet during our scheduled finals time. So on that day, we're going to do a potluck. And I encourage you to bring any parasite-themed meal that you want. And I will probably bring some spaghetti. And after seeing that image, spaghetti just never really looks the same. It always reminds you a little bit about a bowl full of intestinal roundworms, which is always fun. I might actually maybe I'll bring both, of a Rice Krispie treat molded into the image of some kind of a single-celled parasite. And so Ascaris, as you look at this life cycle, how would you describe it? Is it direct, indirect, complex, simple? Yeah, it looks really simple, right? It looks fairly like a direct life cycle in that we become infected by consuming the eggs and not by consuming or interacting with intermediate hosts. But notice there's an arrow pointing from the intestines to the lungs. Do you see that? In step 6, there's an arrow going from the intestines to the lungs. And so what happens, this is, we'll talk about this in a second. So this is what happens. You consume material contaminated with the eggs. And these eggs will live almost forever. I mean, these eggs will survive for decades in the soil. And so you eat something contaminated with these eggs. The eggs hatch, and those larvae burrow through your intestinal wall into your bloodstream, are carried from there through the heart, into the lungs, burrow through the alveoli, crawl up the trachea, get coughed up, swallowed, and then end up back in the intestines. And so they do something very similar to the hookworms, right? Hookworms penetrate your feet, end up in your bloodstream, go through the heart into the lungs, burrow through the alveoli, get up the trachea, coughed up, swallowed, end up in the intestines. But they didn't start there. Ascaris lumbricoides starts in the intestines, goes through this really complex journey to end up back in the intestines. It's very strange. Very strange. And so the question is, why do they do that? And so on the surface, it is certainly a direct life cycle. But it actually has the elements of a complex multiple host life cycle, except for it's multiple tissues in the same host versus multiple hosts. Okay? And so many people suggest that this parasite used to have an intermediate host and no longer does. And now we are both the intermediate and the definitive host. But that also brings up the question, is this how parasites that have complex life cycles actually started? Where they just used multiple tissues in the same host, and from then used actually a different host altogether to accomplish the other task. Yeah. All right, so some of the pathology, estimate about 1/4 of the world's population are infected, and there's basically, the pathology is dependent upon where the worms actually are. So there's pneumonitis, swelling of the lung tissue, when the parasites burrow through the alveoli. That tends to be pretty rare unless you have a huge number of worms doing that all at the same time, which is usually pretty rare because most of the time you're going to be exposed by eating contaminated materials, and the contamination is not going to be super high. This parasite can move across the placenta, so there could be some pathology there of some inflammation in the lining of the placenta. Most of the pathology associated with this is with really heavy infections and getting an intestinal blockage, or actually having the worm burrow through the intestinal wall, and that's really, really bad. And at that point, you usually die pretty quickly once you have your bowels are perforated. You usually die of a systemic infection after that. So treated same way a lot of nematode worms are, mebendazole or ivermectin. So Toxocara canis. This is the main reason why you should deworm your dogs. This is the main reason why you should deworm your dogs. So this is an intestinal parasite in dogs and cats. So Toxocara canis, Toxocara cati, they're morphologically identical. And so it functions a lot like Ascaris lumbricoides does in humans, but in dogs and cats. The problem is when this worm ends up in our bodies, like if you consume the eggs, material contaminated with the eggs, the worms wander around your body looking for the intestines of a dog. And they're not going to find it. And so this is the main cause of what's called visceral larva migrans, where you have larval worms migrating through your organs looking for dog small intestines. They're not going to find it, but they can cause some really devastating pathologies along the way. And so this is probably the most important reason why you deworm your dogs. And so that your children or yourself are not likely to eat material contaminated with these eggs. And I know what you're thinking, like, well, I'm not going to eat something that my dog pooped on. Good for you. But the thing is even after you clean that up, those eggs are in that soil for a long period of time. You go out there and pull a flower out of your grass, right? Because you got a weed in your grass and you pull it out. Maybe it's contaminated with the eggs. You don't wash your hands super well. Now you consume some of these eggs. Kids, it happens mostly in kids because kids are disgusting. Especially happens mostly at parks, dog parks without good leash laws, where dogs will go and poop in the sandbox or poop wherever, and the kids are, playing around, touching everything and putting their hands in their mouth because they're disgusting. Disgusting. So, yeah, that's the main reason why you deworm your dogs. If your dogs are dewormed, you don't worry about it because your dogs aren't releasing eggs of this parasite. You aren't worried about the contamination. Visceral larva migrans, some information about this pathology. So these are the 3 genera that are most likely to cause this. Toxocara canis or cati, Balis ascaris, which we talked about already, Balis ascaris, Procyanus, and then Anisakis. And Anisakis we'll talk about in a little bit. So the textbook gives all of about a paragraph this big to Balis ascaris, Procyanus. We spent, most of a whole class period talking about it because I love it. This is my parasite. So as you look at this life cycle, what's the only thing that you can see that ought to be added to it? There's something missing from this life cycle. You're going to have to think all the way back to when we talked about Balis ascaris, which wasn't last Wednesday, but was the Wednesday before it. Speaking of Wednesdays, Kaylee, are you still good to lead our discussion on Wednesday? Do you have your papers to send out to everyone?
I have one right now.
Okay. Okay. All right, and then just make sure you email them to everybody in the class. So are you okay to go the week after Thanksgiving, Hannah? Yeah, you wanted to go this week?
No.
Oh.
No.
Are you going to be gone on Wednesday?
After
This Wednesday?
This Wednesday? No.
Yeah, okay. Yeah. And then Shelby, are you okay to go the week before finals week? Sure. Okay. Well, that was enthusiastic. I love that. Well, because we can shuffle some things around. Okay. All right. Anyone know what's missing from this life cycle? According to this life cycle, what is the only definitive host? A raccoon, right? Raccoons are the only definitive hosts according to this life cycle. Oh, I guess they did put it. They put a little asterisk next to it, and they said dogs can apparently be reservoir hosts. But yeah, dogs are another definitive host for this parasite. So you should have a dog next to that raccoon. Anisakis, oh man, Anisakis, these parasites are so cool. So these are intestinal and stomach parasites in marine mammals. And so the thing is, we oftentimes get this notice that there's the first intermediate host, which is a shrimp, some crustacean. The second intermediate host is a shrimp-eating fish or a shrimp-eating squid. We eat a lot of fish. And by we, I just mean humans in general. You may not like fish. My wife hates fish and doesn't eat any of it. I love fish and eat a ton of fish. And here's the thing. Even eating marine fish, there's some danger in eating the flesh of marine fish that's not fully cooked, because you can get yourself Anisakis, and then this parasite will wander around your body, your organs, looking for the intestines of a marine mammal, which it will not find. So you could, in fact, get yourself an infection with Anisakis, but you know what? It's worth the risk. It's worth the risk because the probability is pretty low, unless you eat the whole fish. Because most of the time, these parasites are restricted to the stomach of a fish or the area around that. And most of the time, if you're pretty careful with how you clean the fish, you would see them. And they're obvious, and it's kind of cool if you ever butcher a fish. Usually only find it in marine fishes.
So we can bring fish to our...
Yeah, absolutely. Yeah, absolutely. Yeah. Bring some sushi, which is something that you always, have some conversations about when you're thinking about a parasitology class. All right, any questions about these? So your three most likely genera to cause visceral larva migrans, where the larval worms are migrating around your intestines or your organs looking for intestines, are Toxicara, Balis ascaris, and Anisakis. All right, chapter 27 on pins and needles. So this we're going to talk about pinworms. And so here's pinworms Enterobius vermicularis. And so these parasites are similar to lice, in that once somebody in the house gets it, virtually everybody in the house gets it. Now lice are a little bit different in that if your hair is short, it's tough to get lice. But pinworms, you don't have that same issue. So pinworms are an intestinal parasite. And pinworms are interesting in a number of ways. So pinworms are what are called haplodiploid. And so I don't know if I have that written down on a slide. but you should write that down. Haplodiploid. Haplodiploid. One word, and it's kind of like haploid diploid, but just sandwiched together. Haplodiploid. And what it means is the males are haploid, only have one copy of the genome. The females are diploid. And this is how a lot of wasps and bees are, that the males are haploid, the females are diploid. But this seems to be relatively unique among nematodes. So they are haplodiploid. Another interesting thing about this is it seems to be only the females that are really well known. It's pretty hard to find the males of this species. And so this is an intestinal parasite, but it's not in the small intestines. It actually lives in the large intestines. And at night, the female scoots, I don't even know if you'd want to say crawl, let's say moves out of the large intestine through the anus and goes and lays eggs in the perianal space around the anus and then climbs back in and goes back to work. Sometimes these eggs can hatch within minutes of sitting at that body temperature. And the larvae can just follow mama right back in. And we call this retroinfection. And but oftentimes what it does is when they hatch, it creates an itch, or just the presence of the eggs create an itch, and kids have terrible hygiene. So they just stick their hands right in their pants to scratch and then not wash their hands. And then just anything they touch now gets contaminated with eggs. And you breathe them in, you touch something, don't wash your hands, and this is why if somebody in your house gets pinworms, almost always everybody in the house gets pinworms. And it can become really difficult to eradicate your house of pinworms, similar to eradicating your house of lice. All right? So it also doesn't respect social status. It doesn't care. Like you can have the cleanest house ever, but your kid goes to school with a kid that has a horribly dirty house, and now your kid gets pinworms, and then your kid's pinworms give it to everybody else. And so as you look at this life cycle for Enterobius vermicularis, is this a direct or an indirect life cycle? Direct. So you get it by consuming eggs or the larvae and not consuming intermediate hosts. There's no intermediate host for this. Get it from consuming eggs. And if you go and you sample daycares, you'll find millions of pinworm eggs just gathering in the dust in those rooms, which is why, in daycares you tend to have high levels of cleanliness. You get to, they're cleaning all the time in between because it's just nasty is what it is.
I already get another reason not to have kids.
Another reason not to have kids. I could probably add some things to that list. But there are three main reasons why you do have children. One, tax credit, not just a tax write-off, but an actual tax credit if you make under a certain amount. Two, they really do make for great slave labor once they get to a certain age. And then third, they do make a nice fashion accessory, Like if you really want to make your outfit pop, just put your kid in something that either, accentuates what you're wearing or just adds to it a little bit. Or, you got a 3-piece suit on, put your son in a 3-piece suit, and man, it looks sharp. So, all right, chapter 28. So this is a really interesting parasite, not one that you interact with very much. Spirocerca lupi. And so this parasite infects the esophagus of dogs. And basically what it does is it just leads to an enormous amount of material being packaged around these parasite worms. And so what you end up getting is this massive tumor in the esophagus called a sarcoma that's just packed full of connective tissue as your immune system's trying to wall off this parasite from the rest of the body. Now, it is possible to get those in other areas. So you got hypertrophic pulmonary osteoarthropathy, where you can actually get these forming in the trachea and in bronchi. But most often it happens inside of the esophagus. So dogs tend to get it from eating intermediate hosts. This is a parasite with an indirect life cycle. And so your dogs aren't eating material contaminated with eggs or eating or eating larvae. They are eating intermediate hosts, usually dung beetles, which are restricted to warm areas, mostly tropical and subtropical. All right, that's it for chapter 28. Ooh, look at that effect. That was fun. Oh, man, another one. So chapter 29 is where you get some of your most interesting nematode parasites. And one of these causes a disease referred to as Elephantiasis. And we mentioned this before, but not in a while, where you see that root iasis at the end of a word. It means infection with whatever came first. So you have like Ascariasis, which would be infection with what? Ascariasis. Infection with what? What comes before the iasis? Yep, so these are Ascaris worms, like Ascaris lumbricoides, right? You have Anisakis, infection with ancylostoma worms. And so you tend to have, the name of it tells you what causes the infection. But we have this pathology referred to as Elephantiasis, which literally means infection by elephants, which makes absolutely no sense, except that some of the pathology of this actually makes your limbs look like the limbs of an elephant. And so I don't know if historically the assumption was you got this by interacting with elephants and you did in some way become infected with them, but it's not true. You're infected with a nematode worm. And so probably we would be better to refer to this as Bancroftian filariasis rather than to refer to it as Elephantiasis. And so you could also call it lymphatic filariasis. And so these tiny nematode worms live inside the lymphatic system. The lymphatic system basically functions like the sewage system of a city. So, or think about the sewage system of your house. So water enters into your house through your pipes or whatever. Use that water to take a shower or use that water to flush down something you don't want to look at, right? And then all of that water leaves your house through the sewage system. And the lymphatic system is very similar to that. So water and materials will enter into tissues from the bloodstream, and then water and materials have to leave those tissues through the lymphatic system. And so the lymphatic system, again, it works like a sewage system. What happens when the sewage system backs up? If you get a clog in the sewage system. So think about in a toilet, right? What happens when a toilet clogs? Does material keep moving into it and beyond? No, everything backs up, right? And so this is the same thing that happens if you've got parasitic worms in your lymphatic system. They can cause a blockage. And so all of that fluid starts to build up. And so in the toilet, hopefully you get to it and you fix it before it starts running over the edge of the bowl. But if all of this fluid starts building back up in your tissues, something really strange starts to happen. You start to get swellings like this, like these ankles here. So this is caused by a clogged lymphatic duct or lymphatic, not a lymphatic duct, a lymphatic node by these parasites, by these Wuchereria bancrofti parasites. And so this fluid starts to build up and pour back into the tissues and starts to have a number of really interesting, intriguing pathologies. But ultimately, it ends up giving you limbs that just don't look normal. So the most common places to get clogged ducts are in the lower limbs and in the lower abdominal area. And so a lot of times you'll have males with Bancroftian filariasis where fluid starts to build up in the scrotum and you end up getting an enormous amount of fluid building up there. And so here's the life cycle for this parasite. Would we call this a direct or an indirect life cycle? Indirect. And so what is the intermediate host? A mosquito. And this is one where the intermediate host, we're not eating them usually, but as the mosquito feeds, it transmits the parasite to humans. And so the adults, again, they live in the lymphatic system, and the adults give birth to larvae that migrate basically from the lymphatic system into the circulatory system at night when the mosquitoes feed. So this is really challenging. If you were to go and take a blood sample from somebody that was infected with Bancroftian filariasis, if you took a blood sample from them during the day, you would not find any of these larvae. If you took a blood sample of them at night, you would find the larvae in the bloodstream. And so these larvae illustrate something that's called periodicity, that they're only in the bloodstream at night when the mosquitoes that they use as intermediate hosts are actually feeding. It's very interesting to know what triggers those larvae to move from the lymphatic system into the circulatory system. All right, so here are some of the pathologies associated with this. Now, I will tell you that there's not a great deal of research that's going into this parasite because, for the most part, it is restricted to very rural areas and very economically poor areas. Very rural areas and very economically poor areas. However, there are some pathologies that are important to note. So notice it is possible to have, to be asymptomatic. And so you could even have a large number of larvae of the parasite, and you should have some blockage, but you don't. And the main reason for this is even though there are a ton of adult worms and there are a ton of larval worms, your immune system is not reacting to their presence to cause the inflammation. And so what tends to cause the pathology of this is the inflammation. Is your immune system starts to react to their presence, your lymphatic system becomes inflamed, and then at that point it becomes much easier for a blockage to ensue. Because now instead of the wall of these lymphatic vessels being really thin, they start to get a lot thicker, and it becomes a lot more likely that you're going to get clogged and start to have fluid backing up into the tissues. So it is possible to treat this with albendazole to try to kill the worms. Most of the time you treat it with pressure bandages. If you wrap it up real tight, it forces fluid into the lymphatic system and could usually blow out that blockage. And then you could also surgically remove the lymph node. So, I mean, you could do that all the time. If you ever have a biopsy done and they find out that you have some cancerous growth in areas, they usually remove lymph nodes in surrounding areas to try to see if the cancer is spread to there. Again, knowing that the lymphatic system basically is acting as a sewage system. So if it's spread anywhere, it's going to spread there first. And so you can remove some lymphatic nodes, some lymph nodes, and remove the adult worms that are in the node. All right, so this is one type of what we call a filarial worm, Wuchereria bancrofti. Another parasite, another filarial worm, is Onchocerca volvulus. Onchocerca volvulus. Now, I will tell you this. All filarial worms use an insect as an intermediate host. So all filarial worms, Wuchereria bancrofti, Onchocerca volvulus, Loa loa, Dirofilaria imitans, all of these use an insect intermediate host. So Onchocerca volvulus does not use a mosquito as an intermediate host. Instead, it uses a black fly. And so the adults of this parasite do not live in the lymphatic system. They actually live underneath your skin. They are what are called subcutaneous parasites. So they live underneath your skin. You usually see them as some kind of a nodule, illustrated here, where you would have adult worms living in this subcutaneous space. And so, like Wuchereria bancrofti, these parasites proliferate, and the larvae are underneath the skin. And as these black flies feed, they bite, and they cut your skin, get your blood to pool, and then lap up that blood. Well, if there's some larvae that end up in that blood from cutting in an area near where these adults live, then the black fly will now become intermediate host for those larvae. They'll get to the infective stage to where that black fly feeds on someone else. It can deposit those infective larvae to the new host. Now, structurally, the lining of your eyes are very similar to the lining of your skin. And so a lot of times you'll have this parasite, and these flies will bite in the area around your eye, and the adults will end up living subcutaneously in your eye, which will destroy your eye, build up a lot of scar tissue, and light won't be able to penetrate anymore. And that's why you see that quotation, river blindness. That's a common pathology of this parasite, is to go blind under heavy infections. So when you look at this life cycle, is this direct or indirect? Indirect life cycle, and black fly acting as intermediate host. Notice that there's actually some development, and that's how we know that this is an intermediate host and not a different type of host. What type of host helps the parasite to spread but is not necessary for development? Paratinic host. But see, you can see that it develops from first stage larvae to the third stage larvae. And so since the parasite actually develops in this host, this is properly referred to as an intermediate host. All right, so here is a video, and you can find this video. Let's see if it's still part of this. Yes. A little video on Bancroftian filariasis.
Jina langu naitwa Hanani Siro. Ugonjwa huu ulinipata mwaka wa 99 mwanzo unaanza. 99. Wamekuja polepole na ulikuwa una design mbalimbali za maumivu. Kitu kinatembea na kina supply magonjwa mbalimbali. Tumefikia mwisho teremka chini ukafura hivi. Ugonjwa ambao niko nao sasa, ugumu wake ni kwamba nisikia ni uzito wa huku chini. Tena fikiri ukashikilia hivi unapata kama kilo 3 hivi. Uzito peke yake. Unabeba mzigo. Siwezi kujua kama kuna matibabu gani ambayo mimi itaponesha ugonjwa. Ninatamani pote.
But today might just be Karani's lucky day. Sami Njenga is a medical researcher who spent years working to eradicate elephantiasis. And today he's come to tell Karani that a free medical clinic has been set up in a neighbouring village and that he's made an appointment for him to see a specialist.
Habari yako mzee? Nzuri mzee. Habari doctor? Nzuri. This community and other communities along River Galana, they are historically known to be endemic for lymphatic filariasis, commonly known as Elephantiasis. The disease is transmitted by mosquitoes. The same mosquitoes that transmit malaria, they transmit lymphatic filariasis.
Aya, mwingine akuje. Yes, salama namna gani? Okay. Shika tu pale pa salama kabisa. Okay, wewe unaitwa? Karani, kaa tu pale basi unieleze. Okay.
Ninaenda kwa waganga, nikaenda kwa madaktari. Ule ugonjwa basi ukapanda zaidi hata ikabidi nikawa mimi nimekata shauri ya kuwa mimi nitakuwa mzima mpaka sasa.
Okay. Sawa basi, wacha tuangalie kwanza ile shida vile ilivyo, alafu tutakwambia ni kitu gani labda tutatufungulia tuone. Fungua tu kwanza ndio tuone kama utapanda, tuone vile ile shida vile inakaa, na tuone, fungulie tu kabisa, labda tuone, ndio tuone vile. Sema ni miaka kadhaa, miaka 11, miaka mingi pale, unaona pale, na pale unaona damage ambayo iko pale ni mingi, yani uharibifu ni mwingi pale, ndio na umeona kwamba hiyo ugonjwa pia inaanza kuathiri hata mguu yako. Sio hata mguu yako pia inaanza hiyo mguu yako inaanza kufura pale. Ukiangalia hapo juu umefura pia. Ni kitu ambacho unahitaji kupeleka hospitali, tukulaze hospitali. Utakaa hospitali kwa muda, kwa maana hii ni kitu ambacho itafanyiwa operation ambayo itafanyiwa kwa stage. Tutafanya stage ya kwanza, tufanye ya pili na ya tatu. So kitu muhimu ni kwamba ujue kwamba ni kitu ambacho itatengenezwa, lakini itakuweka kwa hospitali kwa muda. Yeah? Okay. Siku tutakupangia. Okay. Yeah, along the Kenyan coast, what you have just seen is a fairly common thing. Common in the sense that actually when you go looking for it in the villages, you'll find them. Uncommon in the sense that these people don't come out to be seen. You've just seen the kind of morbidity they're carrying. It does not allow them to move from one place to the other. It stigmatizes them. They cannot come out to come and show what they have. So everybody in the village knows they're there, but they don't come out. But when you go looking for them, you just find most of them are in the village. It's very common.
And so there have been some actually pretty big successes in trying to eradicate this parasite from various areas. A lot of it's done with education, with knowing that the mosquitoes that transmit this feed at night. When you sleep under a mosquito net, and so it's not going to be the same mosquitoes that you're interacting with during the day. They're not going to be transmitting this. And so there are some really good ways of eradicating this, but the problem is, and he illustrated this, that the people that have it, there's somewhat of this stigma associated with it, which makes sense to an extent, but it makes it to where there's a lot of shame associated with it, and they try to hide it. And by the time it gets to a point where they can no longer hide it, they're at a point where the damage is really devastating. And so you find that with a lot of these filarial worms as well. Same thing with Kosuke Volvulus. When you start to notice these nodules, you just kind of hide it, not wanting to demonstrate that you have some kind of a disease that people may fear that they may get from you. And so by the time you will admit it, you're usually at a very advanced stage. So there's another filarial worm that has an affinity for the eyes. This one is not transmitted by black flies, but instead is transmitted by deer flies. Chrysops is the genus. And this one is almost always in the eye. So Kosuke Volvulus is sometimes in the eye, and when it does, can cause some devastating issues. But Loa is almost always in the eye. And so you can actually see in this image the adult worm living underneath the surface of the eye right there. And so it is quite obviously referred to as the eye worm. And so here you can see again that indirect life cycle. How do you know that the deer fly is an intermediate host and not a paratinic host? The parasite's actually developing inside of that host. You see that? Going from the first larval stage to the third larval stage, the infective stage. All right, Dirofilaria emittens. This is the second biggest reason why you deworm your dogs. So the first one is Toxocara canis. The second one is Dirofilaria emittens. This is the dog heartworm. It's pretty common. If you go on YouTube, you can find tons of videos of surgeries where they've removed hundreds of these worms from a dog's heart. They can usually do it and keep the dog alive, but you do have to surgically remove them, and it can be a long recovery. But this filarial worm, the adults end up in the heart, and the larvae end up in the bloodstream of the animal. And as a mosquito feeds, it will take in those larvae. The larvae will develop to a point at which when the mosquito feeds on another individual, it can drop those into the new individual. So this is zoonotic. They don't mature. They don't reach sexual maturity and reach adulthood in humans. but you can get a number of these larvae swimming around in your blood, which can trigger an immune response. And you can have a systemic-wide response to the presence of that parasite. And so it can be incredibly dangerous in humans, and is the second biggest reason why you should deworm your dogs. All right, the fiery serpents. So this is the last group of parasites we'll talk about for this section, just in nematodes in general. So Dracunculus metanensis. This parasite has almost been entirely eradicated from humans. It is probably one of the biggest success stories against a parasite that looks like it only does harm and no good. And so this is a parasite we've known about for a long time. You see writings of it throughout early literature from the Middle East and from Africa, where this parasite is endemic. But some argue, and I think fairly convincingly, and we'll talk about this more in a little bit, that when Moses or God punished some of the Israelites with the bite of a fiery serpent, and they had to look on the image in order to be healed, that this is what was actually going on, that they were infected with this parasite. Because the pathology associated with it is supposed to be very, very similar to the feeling of being bit by a snake and the inflammation that's caused from that. So this is interesting. You can see in this image here an adult female sticking out of this wound. And so this adult female will start to lay a bunch of eggs in here, and it'll form this blister, and you'll build up a lot of fluid, and then it'll pop, and those eggs empty out into the water. And so the juveniles, the eggs have already hatched. So it's not the eggs that are eliciting the immune response, but it's the juveniles. And then so you'll get a blister, incredibly painful, that then will rupture, and the juveniles can enter into the water. At which point they need to be eaten by the intermediate host, which is usually a copepod, a type of crustacean. And then from there, humans would get it by drinking water contaminated with the copepods. These are microscopic organisms, very hard to know and to see in your water. One of the reasons why you should always boil water, unless you know it's come from an area where it's been treated well. Now, you find a number of species in this genus that are still common in wild animals that regularly drink fresh water that's not processed and consume a lot of these copepods. And I think I mentioned this before, but you find this a lot in raccoons. And they would ask me, the fur trappers I worked with to try to get my raccoon samples, they would ask me a lot about these parasites that they would find in the ankles of the raccoons. And so here's the life cycle. So it is an indirect life cycle. It has an intermediate host. Now, it seems to be that we may actually have been the original host for this, but I don't know whether or not that's the case. All right. So the way you treat this is you basically have to slowly wind the female worm out of the host. And the female worm may be 8-10 inches long or longer. And if you pull too hard, she'll tear apart and would elicit just an enormous immune response that would be very, very bad for that host. So you have to slowly wind them out, usually around some kind of a stick, and you wind her out about 1 millimeter at a time, about 1 millimeter per day. And then so for several weeks, you have this stick with a female worm wrapped partially around it, and every day you wind it a little bit further until eventually you pull the whole female worm out of your leg. And so even getting this female out is incredibly difficult. And so there's not an effective drug treatment to kill the female. You just have to wind her out or surgically remove her without allowing her to rupture inside of the host. And so here you can see an image of this female partially out of this person. And so again, it's just a really slow, painstaking process. The caduceus, the symbol for medicine, most people, so you've got like that, you know, I think I have it in the next slide. Yeah. So there's the caduceus, and there's another one. A lot of people think the origins of that symbol are in this treatment of this parasite, because it's a very effective, very obvious way of treating this and getting rid of this parasite is winding it around a stick. So here's a passage from Numbers. Then the Lord said to Moses, make a fiery serpent and set it on a standard, and it shall come about that everyone who is bitten, when he looks at it, he will live. And so the idea there is that what Moses is doing there is basically showing the people, how do you eradicate yourself with the parasite? You know, there's some interesting similarities there. The pain of the blister has actually been interpreted to say being the bite of the snake. Serpent on a pole, what was actually set up, could represent the worm on a stick, winding it out. And the Israelites at that time were in a region where this parasite is endemic. The interesting thing is, the pathology of this parasite is usually not devastating enough to kill people, unless, of course, you're trying to pull this worm out all at once and you're not doing it the proper way. So it is interesting, it is intriguing to wonder, is that what was actually going on at this time? Is this what God used to actually teach them a lesson? Or was it actually a serpent? Because it's interesting to understand if in Hebrew, when they're talking about serpent, if they actually mean a snake or if they mean a worm. You know, it's not always super clear. And so there's some thoughts. This is presented in the text, and I think is just an interesting case of where, yeah, it's just not super clear, and it could absolutely be a case of this parasite. All right. Any questions on any of our nematodes? So I'm pretty sure that it should be time this week for the 4th research abstract. And so I need to, Kaylee's going to send you out some papers for her discussion on Wednesday. I am going to today post a question, a research question for the 4th research abstract. And as with previous research abstracts, you are welcome to turn it in ahead of time. Only one person did it on research abstract number 3. Only one person turned it in ahead of time. But then that person didn't send in a second edition and just stuck with the first edition, which is fine. But you can turn it in early, and I can make some comments and give you the opportunity to turn it back in. So that's happening this week. And then the only things left on the schedule are you 3 have yet to lead your discussion. So Kaylee, you're going this week. Hannah, you're going to go the week after Thanksgiving. Shelby, you're going to go the week right before finals week. And then we have the 2 more research abstracts and our final exam and a couple more quizzes. So we're getting towards the end of our experience together, which may be encouraging or discouraging, sad, happy, I don't know. But we're getting towards the end, and as part of that just comes a lot of things are going to start to roll in all at the same time. So as you're working through any of this, if you have questions, let me know. If you want some help with your research abstract, in addition to me just making some comments, let me know. But I'll have that question out today.
Question about the quiz for this week. It was like posted, but were we supposed